Good morning, seventh grade. Today we're going to do a quick video about solving one-step equations. And a one-step equation is going to be something that looks like 2 plus x equals 7, or x minus 11 equals 20. This is this is addition and subtraction. Multiplication would be 2x equals 16, something like that. Or x divided by 4 equals 36. So what you're looking for is adding, subtracting, multiplying, and dividing. Here's what the styles look like. And we're going to go through the ways that you are going to go ahead to solve a one-step. So I want you to think about yesterday when you were doing your balance beams on Wednesday and Thursday. And we haven't used this word yet, but it's what you were doing the entire time. You solved every equation by using inverse operations. And inverse operations mean you do the opposite operation. And when you use the opposite operation, that will undo the part of your problem that is in there. So if I give you an addition problem, like we did in hands-on algebra, when you were taking cubes or taking pawns away, you were actually solving the problem by using subtraction. Now, multiplication division, that's something new. I'm going to introduce that and what it looks like today. But if you do a multiplication problem, then the way that you solve it is by dividing, and then the opposite, a division problem will solve by multiplying. So really quickly, we are going to do an adding problem. The inverse operation will be subtracting. If it's a subtracting problem, you will actually solve it by adding. Multiplication is solved by division, and division is solved by multiplication. So you are always doing the opposite. That's what these arrows mean. It means subtraction is solved by addition. That's why the arrow goes both ways. Addition is solved by subtraction as well. Now, just like in hands-on algebra, when we wanted one pawn at the end of the day, that was called isolating the variable. If I want you to isolate a variable, I would like you to use the inverse operation to get the variable alone. The word alone means I want one variable left, or the x or the y by itself, okay? Now we're going to do this every single time. You're going to use inverse operations until the variable's alone, and then we have a solved answer. So today is only one steps. So what you're going to do today is you're going to look at an example like this. So we are going to draw, like this says upside down T. This is your balance beam. So when I get a problem that is x plus 2 equals 7, the first thing is through the equal sign, you're going to draw on your balance beam. So you're keeping it just like you did with hands-on algebra. Now, the inverse operation is what I need to look at. This problem is adding 2, and my variable that I want to isolate or get alone is this x. We're not worried about anything over here yet. So the inverse operation, the opposite operation of adding 2, is subtracting 2. That's how you get a 0 pair to get rid of that 2. But because it's a balance beam and you learned with hands-on algebra, if I do it to this side, I need to do it to this side. So if you look at step number 2, that's this part clean and drawn out for you. The balance beam is in place. You have an inverse operation of -2 happening, or -2 from both sides, and you are finished when you have an answer with just an x, isolating the variable, and an answer of 5. Now here's the check part. Here is your original problem. X plus 2 equals 7. You now know that x equals 5, so you are going to substitute it in your problem anytime you see an x. So the x no longer exists once you get an answer. X is now 5, 2 is in your problem, and just like yesterday, if 7 on the left equals 7 on the right, and you are done, you have a checked problem. We are going to work through the problems at the bottom. I'd like you to pause the video and then watch. I want you to do these two first. Okay, now that you've done your check, here is your isolating the variable a. The inverse operation of adding 8 is subtracting 8. It happens on both sides, and I have my balance beam to prove it. I have just an a left, and 20 minus 8 is 12. When I plug it back in, a is now 12. I get 12 plus 8 equals 20. That's a check. For the second one, isolate your m, use inverse operations to do it. Minus 9 and adding 9 or positive 9 are your zero pair. Whatever you do on the left, you do on the right. And so m is the only thing left on that side, equals 24 on the other side of my balance beam. So when I plug it in, I get 24 minus 9 equals 15. Now, this next problem is the first time that you've seen a multiplication problem. This means 3 times m. So you're still going to draw your balance beam in. And if you remember at the very top of our paper, multiplication is undone through division. So down here, I'm going to say m times 3 equals 12. I need to share these 12 pieces with 3 m's. So just like yesterday, you divided both sides by how many m's you have. Divided by 3, divided by 3. My answer, m equals 4. So if I put it in, 4 times 3 equals 12, and that is a check. Now, this is how they show division, but in Mrs. Deshone's classroom, it will look like this, because this is our 7th grade or advanced way of showing division. Anytime you see a fraction bar, that means divide. So when I put my balance beam in again, I'm going to multiply this side by 4, and I'm going to multiply this side by 4. Now, pretend it's 4 over 1. These 4s are going to cancel out exactly like we want them to do. This is our version of a zero pair on the division side. And you get x equals, and 16 times 64, 16 times 4 is 64. So to check it, I'm going to put it back in, and you're going to take your 64 and divide it by 4. Sorry, I dropped my marker. And you get 64 divided by 4 equals 16, and that is a check. What you're going to do now is you're going to flip your paper over. On the back, you are going to practice these problems. So I have some subtracting. This is a subtracting problem, even though it's addition. That's the number you want to get rid of because the t is what you want to isolate. So this one, inverse operation, is going to be with the negative 9. You want to get rid of the negative 9. We have an adding. We have an adding. We had 2 multiplications that are undone by division. We had 2 divisions that are undone by multiplication. So I'd like you to pause the video, complete these 2 words at the top, these 2 vocabs, and complete the problem. When you're done, you can check with me for the answers. Okay, at the top, balance beam happens first. The opposite of negative 6 is positive 6. And when you combine these 2 sides together, I get a positive 18. 18 minus 6 is 12. It checks out when I plug r back in. Number 4, I draw my balance beam. I want to isolate the t. So I want to get rid of the negative 9. So that's my goal, is to keep that t. So get rid of negative 9 would be positive 9, or subtracting 9 is adding 9. And then when I combine these 2, negative 11 and positive 9, I get negative 2. Negative 9 plus negative 2 is negative 11. At the bottom, balance beam, I want to keep the h, or isolate the h variable, so I get rid of the 15. Now, negative 13 and negative 15, you are always combining on this side, give us a negative 28. And when I put it back in, negative 28 plus 15 equals negative 13. The last adding and subtracting problem, I want to isolate the letter C, so I get rid of the 22 by subtracting it. So 30 and negative 22, or 30 minus 22, is 8, which means 8 plus 22 is 30. So now we're going to pause the video, and you're going to work on some multiplying and dividing. Okay, last 4 problems. I want to isolate the x. It's being multiplied by negative 2, so I'm going to divide both sides by negative 2. X equals negative 9. If I follow my integer rules, negative 2 times negative 9 will give me a positive 18. The next one, the x, is the one I want to isolate. It's right here. It's being multiplied by 9, so I have to use inverse operations and divide by 9. So I get both sides divided by 9, x equals 7. 9 times 7 equals 63. That checks. The 2 division problems look like this. Instead of dividing r by 5, I want to multiply by 5 as the inverse operation. The opposite of dividing is multiplying. So if I multiply both sides by 5, I get an r equals 50. So that means 50 divided by 5 equals 10. that checks out when I plug it back into my original problem. I gotta highlight that. Sorry, we're isolating the R. On this one, we're isolating the W. So I want to get rid of the dividing by 4. You get rid of the dividing by 4 by multiplying by 4. So W equals negative 32. So if I check it, negative 32 divided by 4